Hello, dear students. Assalamu alaikum. So today I'm going to solve Cambridge S level mechanics paper 4, and I'm going to solve February-March 2022. That means the latest mechanics paper. So let's start. The first question is related to work, energy, and power. It's a very simple question because the question is having only 4 marks. And as this is the first question of the paper, so that's going to be quite easy. Okay, so at first let's go through the question. A crane is used to raise a block of mass 600 kg vertically upwards at a constant speed through a height of 15 meters. There is a resistance to the motion of the block which the crane does 10,000 joule of work to overcome. So that means the crane is raising a block of mass 600 kg with a constant speed. So that means there is no change in kinetic energy because the speed is constant. And as the crane is lifting up the object to a certain height, which is 15 meters here, so that means the gravitational potential energy of the object is going to be increased. And at the same time, to overcome the resistive forces, the crane has to do a work of 10,000 joule. So overall, the total work done by the crane, that's what we have to find out. So total work done will be, gain in gravitational potential energy because the crane is moving the object to a certain height. So gravitational potential energy is mgh, and at the same time, to overcome the resistive forces, the crane is doing an extra work of 10,000 joules. So mass is 600 kg, value of g is 10, h is 15. So total energy is 1 lakh joules. Okay, so that's very simple. Now let's move on to question. At average power exerted by the crane is 12.5 kilowatt. Find the total time for which the block is in motion. So think about it. The crane is spending 12.5 kilowatt of power because that is needed to increase the potential energy of the object and at the same time to overcome the resistive forces, right? So that means we have to consider the total energy that the crane was spending. So we know the formula, power equals to work done divided by time. So here power is 12.5 kilowatt. So that means 12.5 into 1000 watt. We need to convert it into watt. And work done is the total amount of energy spent by the crane. That was 100,000. And time we don't know yet, so make t as the subject, so the value is going to be 8 seconds. So that means the crane was in motion for 8 seconds. So that's quite easy. So let's move on to next question. Let's go through the question first. A particle P is projected vertically upwards from horizontal ground with speed u meter per second. P reaches a maximum height of 20 meters above the ground. Find the value of u. We have to find out the velocity of the projection. So initial velocity is u meter per second and maximum height is 20 meters. So we all know that at maximum height, the final velocity is going to be 0. At maximum height, the final velocity is going to be 0. So we can use the formula. Okay, at first, let me draw the figures. It will be easier. U meter per second, that was the initial velocity, and object is moving to a height of h equals to 20 meters. So at maximum height, the final velocity is 0. At maximum height, the final velocity is 0. Initial velocity is u meter per second, and final velocity is 0 meter per second. So v square equals to u square minus 2gh. Negative acceleration, why? Because it is moving against the gravity. So that's why definitely the sign of the gravitational field strength or acceleration due to gravity is going to be negative. So the final velocity is 0. Initial velocity, we don't know yet. The value of g is 10. Value of h is 20. So make u as the subject. The value is going to be 20 meters per second. So that's the initial velocity. Okay, so let's move on to B. Now in question B, find the total time for which P is at least 15 meters above the ground. find the total time for which P is at least 15 meters above the ground. So we already know that the velocity of projection is 20 meters per second and the maximum height was 20 meters. So say for example, that's the maximum height from the ground level and that was 20 meters. Now the question is, for how many seconds or for how much time the object is above 15 meters from the ground. So if we consider this is as 15 meters, if we consider this is as 15 meter height, then for how much time the object was above 15 meters? So this duration of time we have to find out. So if we want to solve it, so we have to at first form an inequality. We can use the formula S equals to ut minus half gt square. Now think about it, the displacement, the value of S has to be greater than 15. For how much time? P is at least 15 meters above the ground. So S has to be greater than 15 meters. So ut minus half gt square, that has to be greater than 15 meters. So now we have to solve the inequality. We know the values. When we multiply both sides of an inequality, the inequality sign is going to be changed. So that's a quadratic inequality. At first we have to find out the critical value. Critical values are 1 and 3. And as the coefficient of t square is positive, so the graph will look like this. Now the inequality here is less than 0. Less than 0. So we have to consider this part of the graph. This part of the graph is less than 0. So that means when we are considering the time duration from 1 second to 3 seconds, when we are considering the time duration from 1 second to 3 seconds, at that moment the total value will be less than 0. So that means for this inequality, the corresponding answer is going to be 1 to 3. So that means from 1 second to 3 seconds. 1 second to 3 seconds. So that will be the answer. Now think about it. The question was asking find the total time for which P is at least 15 meters above the ground. So for the time duration from 1 second to 3 seconds, the object will be at a height of at least 15 meters. So the time duration 3 minus 1 seconds, 2 seconds. So that will be the final answer. So I think you have understood. So we are done with question 2. So let's move on to question 3. Let's go through the questions. Question first. A car of mass mkg is towing a trailer of mass 300 kg down a straight hill inclined at 3 degrees to the horizontal at a constant speed. So at first we have to draw a well-labeled figure. It's not necessary. There's no mark for that, but actually if the diagram is well and clear, so it'll be easier for you to find out or deduce the equations that are required to solve the question. So an inclined surface and the angle is 3 degrees with the horizontal. 3 degrees with the horizontal, and A car of mass m kg is towing a trailer of mass 300 kg down a straight hill. So that means the car and the trailer, it's moving in downward direction. So that's the car, say for example, and that's the trailer. It's moving in downward direction, and the car engine needs to spend 40,000 joules of energy for overcoming resistive forces for 50-meter length. So resistive force means air resistance, frictional force, everything is there. Okay, so and the car and the trailer is moving with a constant speed. The engine of the car is doing no work and the tow bar is light and rigid. The engine is not giving any additional forces. So that means the car and the trailer is moving in the downward direction because of its component of weight along the plane, along the surface. Okay, so what we can do here at first, let's find out the resistive forces. So we know that work done equals to force into distance moved in the direction of the force. Now here, work done due to resistive forces is 40,000 joules, and force, resistive force, we don't know that, and that work done was for 50-meter distance. So from here we can find out the resistive force, and that's gonna be 800 Newton. So we have got the resistive forces, and the engine is not doing any kind of work. So an object is moving with a constant velocity. So that means the resultant force is gonna be 0. The resultant force on the car and the trailer is 0. So that means the downward force component of weight, which is mg sine theta, or mg, not mg actually, because the total mass of the car and the trailer is m plus 300. So m plus 300 g sine theta, or g sine 3 degree, g sine theta or g sine 3 degree. For now, it's not required. The resultant force along the plane, will be m plus 300 g sine 3 degree equals to frictional force, resistive force, that is 800 Newton. So from here we have to make m as the subject. The value of m is gonna be 1228.586 kg, or if you round it off, it's gonna be 1230 kg. So that's how we can find out the value of the mass of the car, the value of m. Fine. So we're done. So let's move on to question B. The resistance force on the trailer is 200 Newton. Just on the trailer, the resistive force is 200 Newton. Find the tension in the tow bar between the car and the trailer. So let's draw the figure again for better understanding. So that's the car and that's the trailer. And now at first you need to understand the direction of tension, how we can understand what should be the direction of the tension that is being working on the car and the trailer. So think about it. The car is pulling the trailer. The car is pulling the trailer. So that means the car is creating a tension on the trailer in downward direction. The car is pulling the trailer. So that means the car is creating a tension on the trailer in the downward direction. So according to Newton's third law, the trailer is going to apply tension force in upward direction. And the value of tension in both the cases, it will be definitely equal, because according to Newton's third law, we know that action and reaction pair is always going to be equal. So at first you need to sort out the direction of the tension. And only on the trailer, the resistive force is 200 Newton. Only on the trailer, the resistive force is 200 Newton. So we have to find out the tension. So on the trailer, think about it. On the trailer, In the upward direction, resistive force of 200 Newton is acting, and in downward direction, tension is acting, and also in the downward direction, the mass of the trailer was 300. So 300 G sine 3 degree, it's also acting in the downward direction. So the equation will be T plus 300 G sine 30 equals to 200 Newton. So now just solve it. It's going to be 42.99 Newton. If you round it off to three significant figures, it's going to be 43.0 Newton. So that's the answer. So we are done with question 3. So let's move on to question 4. The total mass of a cyclist and her bicycle is 70 kg. The cyclist is riding with constant power of 180 watt up a straight hill inclined at an angle alpha to the horizon. So the angle with the horizontal is alpha, and it was giving a constant power of 180 watts. So that's really important information. Sine alpha equals to 0.05. At an instant when the cyclist speed is 6 meters per second, our acceleration is minus 0.2 meter per second squared. There is a constant resistance to motion of magnitude F Newton. So we have to find out the value of F. So at first, let's draw a figure to understand the scenario here. So say, for example, this is the cyclist and her bicycle, and she is moving up a straight hill. So that means she is moving in the upward direction. So she is applying some amount of driving force. So let's consider dF, and her component of weight will act in downward direction. That's mg sine alpha or theta. So let's consider theta, the angle. Oh, sorry, the angle is given as alpha. It's given as alpha, so sine alpha. And there is a constant resistance to motion of magnitude F Newton. So resistance to motion F Newton, and the value of F is, we don't know yet, we have to find out in question. So in question A, the total mark is 4. So that means we have to do 3 to 4 steps to find out the final answer. And also the acceleration is even as minus 0.2 meter per second square. So that means it's actually decelerating in upward direction. So what we can do here, as we know the power, constant power of 180 watt, and we know the speed, we can find out the corresponding driving force. So we know the formula P equals to FV. Now you always have to remember, when you are considering a constant power, the corresponding force is actually driving force. The corresponding force here is actually driving force. So let's write down the equation as power equals to driving force multiplied by velocity. Power equals to driving force multiplied by velocity. The power here is 180 watt. Driving force, we don't know yet. And velocity is 6 meters per second. So driving force here is 30 Newton. So we have got the driving force. Now let's make an equation. So the object was accelerating, so downward force. So as the object was accelerating, so in upward direction, it was applying driving force. So driving force minus, in downward direction, component of weight, so mg sine alpha, plus resistive force, we don't know the value yet. So equals to mass into acceleration. Mass into acceleration, Newton's second law. So driving force is 30, mass is 70, the value of sine alpha is 0.05. Mass is 70, acceleration is minus 0.2. Now from here, make F as the subject. If you do the calculation, the value of F is going to be 9 Newton. So that's the resistive force. So I think you have understood. It's not that difficult. Now in question B, find the steady speed that the cyclist could maintain up the hill when working at this power. So that means when it is working at that power, what can be the corresponding steady speed that the cyclist could maintain? Okay, so again, we can apply. So power equals to driving force multiplied by velocity. So power was 180 watts. So the driving force here is 180 divided by V. In the question, they're asking about the steady speed that the cyclist could maintain. So we will consider that V as the steady speed that we have to find out. So now here equation will be, let's go back to the figure again. So the driving force that's going to act in upward direction, and resistive force and component of weight is going to act in downward direction. Now, as they're talking about steady speed, so the resultant force is going to be 0. Resultant force is going to be 0. So that means in upward direction, driving force, and in downward direction, mg sine alpha and the resistive force. Sorry. Resistive force F. So the equation is going to be driving force equals to F plus mg sine. Driving force 180 by V. Resistive force we have found out as 9 Newton in the previous question. Mass was 70 kg, so 70 into 10 into value of sine alpha was 0.05. So from here, make V as the subject. The value of V is going to be 4.09 meter per second. 4.09 meter per second. So that's the steady speed that the cyclist could maintain while applying a power of 180 watts. So that's all about question 4. So let's move on to question 5. So in question 5, 4 coplanar forces are acting at a point. That means all the forces are at the same surface. And the magnitude of the 4 forces are given. The direction of the forces are also shown in the diagram. So we have to find out the value of the force F and G. Now, in case of solving this kind of question where multiple forces are acting in a particular in certain directions on the same surface, always we have to consider, we have to find out the component in the X direction and also in Y direction. So if we can make 2 equations by solving them simultaneously, we can find out the results. So at first, let's find out the sum of component of all the forces in X direction. And sum of all the forces in any particular direction will be 0 because it's an equilibrium. So sum of all the component of forces in any particular direction, it's going to be always 0. So at first, let's find out all the component in X direction. So it's going to be F plus G cos 60 minus twice F cos 40 equals to 0. F is already acting in the right direction, and the component of G will be G cos 60. And look at here, the twice F force is acting in other direction. So it's horizontal direction. In this direction, the component is twice F cos 40, but as it's in the opposite direction of F, so that's why I've given a negative sign. So the value of cos 60 is half, so F plus G by 2. And I'm not going to put the value of cos 40 here because that's going to make the question That's going to make the calculation difficult, because for cos 40 we are not going to get on any fraction value. It's going to be decimal, so we don't want to do it. We don't want our calculation to be difficult. So G equals to twice F cos 40 minus F multiplied by 2. So let's keep it like that. Now, if we take the component in vertical direction, we're considering the upward direction as positive. So we will get T sine 60 plus twice F sine 40 minus 10 equals to 0. So always in case of component, always remember that when you are finding out the component at the side of the theta, that's always is cos component. And when you are finding out the component on the other side of the theta, it's always going to be sine theta. So that's why in vertical direction, the component of G is G sine 60, and the component of twice F in vertical direction is twice F sine 40. And as 10 Newton is acting in opposite direction, so that's why I've given a negative sign here. So now what we will do here, the value of sine 60 is root over 3 by 2. So root over 3G by 2 plus twice F sine 40 equals to 10. Now we have got the value of G here. We will put it here in this equation. So if we put it here, this 2 and this 2 is going to be cancelled out. So root over 3 twice F cos 40 minus F twice F sine 40. So now if we calculate it from here, the value of F is going to be 4.53 Newton approximately, and the value of G will be 4.8. Put the value of F here, then the value of G is going to be 4.8. In this way, you can solve this question, and you can see that the calculation is quite lengthy. Definitely it is, because the question is carrying 5 marks. So definitely you need to do some calculation to achieve that 5 marks. So we're done with A, so let's move on to question B. Now in question B, given instead that F equals to 3, find the value of G for which the resultant of the forces is perpendicular to the 10 Newton force. So let's draw the diagram again. So in this direction, F force was acting in downward direction, that's 10 Newton. He was at a 60-degree angle, and twice F was at the angle of 40 degrees with the horizontal. 40 degree with the horizontal. So find the value of G for which the resultant of the forces is perpendicular to the 10 Newton force. So that means the resultant force is either acting in the direction of F, or it's acting in the opposite to the direction of F. So think about it. If the resultant force is acting horizontally, so that means definitely in vertical direction. In vertical direction, the resultant force is 0. in vertical direction, there cannot be any resultant force, right? So in downward direction, 10 Newton force is acting. In upward direction, it's going to be G sine 60 plus twice F sine 40. Now, as the resultant force is acting in the horizontal direction, so the resultant force in vertical direction definitely has to be 0. So that means we can write down 10 equals to G sine 60 plus twice F sine 40. And in the question, it is given that the value of F is 3 Newton. So 10 equals to G sine 60, 6 sine 40. So now you have to make G as the subject. So if you make G as the subject, it's going to be 7.09. 7.09 Newton up to 3 significant figure. So I think you have understood. So let's move on to the next question. That is question number 6.